Hey, scientists, grab those lab coats and goggles as today we are going to work on comparing and contrasting properties of matter. Let's get into our essential questions.
Now, let's talk about our essential question. Remember, essential questions in science and in different lessons can help us think about what we already know about a topic, and it helps us connect to new ideas that we're going to learn today to help us produce a new thought about the topic. Our essential questions will be focused on our different science topics. So look for keywords. In those keywords, the minute you see them and recognize them, I want you to think, what do I already know about this topic? Once you have that in your mind, you want to look at the question again to see what we're trying to answer today or what are we trying to answer about that topic. It's important to remember that an essential question is like a goal as well. By the end of our science lesson, you should confidently be able to answer the essential question. Let's go over our essential question for today.
The essential questions for this unit all have to do with classifying matter. Let's look at them now. Listen to me first. What are the physical properties of matter? Read that one with me. What are the physical properties of matter? Let's look at the second one. Listen first. How can the physical properties of matter be measured? Read that one with me. How can the physical properties of matter be measured? And our last one. Listen first. How can we compare and contrast matter? Read that one with me. How can we compare and contrast matter? We are going to do a quick activity with a normal Coca-Cola can and a Diet Coca-Cola can. Both of these cans are going to be filled with soda and closed for this activity. Before we start, I want you to make some observations based on the two cans. I'm going to turn it around so we can look at the nutrition facts. That'll give us a little bit more information about the ingredients in the soda, not necessarily the can. Each of these cans, though, is the same shape and size, one being put into the water, so the only thing different is the liquid inside. Let's identify some of the differences that we notice in the nutrition facts on the back of these cans. Pause the video and make a list on the board as a class now. Now that we've looked at some of the differences in the ingredients between Coca-Cola and Diet Coke, I want you to make a prediction. Which can do you think will float and which can do you think will sink? Or do you think both cans will float or sink? While you make these predictions, make sure you give a reason why. State your sentence. I think the blank can will sink or float because, and give a reason why based off the observations you made while looking at the Coca-Cola and Diet cans before. Now let's see if our predictions are right. I have my Coca-Cola can here. As you can see, it's the 12 fluid ounces. It's the same as my Diet can here, both 12 fluid ounce cans. When I put the Coca-Cola can in, it sinks pretty much right away to the bottom. Then when I add the Diet Coke can in, it floats actually. So one of the cans sink and one of the cans floats. Watch, even if I take time and I add a little bit of pressure to the Diet Coke, pushing it down, it still floats to the top. My Coca-Cola can, on the other hand, is still staying stuck at the bottom. Go back and visit your original predictions when you talked about what can you thought would sink or float. Now that we know the final results of which can did sink and which can did float, explain why you believe that the Coca-Cola can sink and the Diet Coke can floated. When making your observations, you might have noticed that the Coca-Cola can has way more sugar than the Coke can. The Diet Coke has no sugar, and the Coca-Cola can has over 30 grams of sugar. It almost has 40 grams of sugar. That's more than 3/4 of the amount of sugar that we are supposed to intake in one whole day. Because the sugar is more in the Coca-Cola ingredients than it is in the Diet Coke ingredients, it adds more weight, bringing the Coca-Cola can down and making it less buoyant. Whereas the Diet Coke can does not have those extra sugar particles or weight in it, so those extra particles are not weighing it down, allowing the Diet Coke can to float. But what does this have to do with matter? When we are talking about the solution that is in the Coca-Cola and Diet Coke can, we're specifically looking at its ingredients and breaking them down into their original states of matter. And that includes sugar. Sugar particles are solids in the beginning, and when they're mixed in with the Coca-Cola cans, they're going to add weight into the amount of Coca-Cola cans and into the density of the liquid that is in the Coca-Cola cans. During your observations, you may have noticed that the total sugars is almost 40 grams. That's over 3/4 of the amount of sugar that we should be eating in a day. You'll be looking at the specifics of a ruler and a paper clip and finding out how their specific states of matter can be identified using specific properties. You'll focus on looking at if the items are magnetic or not, or if the item floats or not. After identifying these key things, you'll be able to make a final conclusion about which state of matter you think each item is representing. While exploring, scientists make sure if you have water at your desk individually or with groups that you be careful for any spillage and you clean them up right away. Have fun with your exploration. Make sure to take good notes for your observations, and I'll see you soon, scientists.